Okay, so today I have an LG 5-disc home theater system. It doesn't work. Alright, so I have it plugged in. The power is on. No response from the power button at all. I'll bring it over here. We'll turn the lights down. And I see nothing. Nothing at all. There is the model number LHT764. Well, since it's dead, let's go ahead and open it up and see what's inside. Here's the inside. Alright, there's the power supply board. Let's go ahead and check the fuse right here and see if it's open. So I have my meter in continuity. Here you can see it. If I short the leads together, I get 4 or 5 ohms and a continuity beep. And the fuse is good. So I do have a schematic here of the power supply circuit. And this is the standby power supply up here with all these rectifiers, so many. And this connector is mostly standby voltages. This is the run power supply down here with just a couple of outputs. So I'm interested in the standby power supply. I want to find out if it's making standby voltage, especially if it has a 3.3 or a 5 volt rail here. I want to check that between the 3.3 and ground or 5 volts and ground. I want to make sure it's getting that because that is what the microprocessor needs. So here's a partial schematic of the standby power supply, and what I'm interested in is pin 7 and pin 8. Which is 3.5 volts, and then down here we have 5.6 VA, which usually means always. So it's an always power supply. Anytime the unit's plugged in, we should have 5.6 volts on pin 12. So let's check pin 7, pin 8, and pin 12. There's pin 12, 5.6. So 7 and 8, I have nothing. So here's a closer up view of the power supply, and I'm looking for pin 7 and pin 8. 3.5 volts. I just checked it. It is not there. But if I follow this back to this regulator, I checked over here on D933 and I have 4.3. But if you follow this line right here, it comes down here and it goes into this connector right here on pin 11, power control. So it's waiting for an input from the microprocessor to say power is good, power up. And when this power control line goes high, it turns on through this 4.7K resistor and through this 4.7K resistor, these two regulators as well as this third one, through another 4.7K resistor. And then we have a 39K resistor that goes to this ground point right here, to keep this line low so it doesn't intermittently spike these to turn on or have leakage voltage cause these to turn on. So I'm going to have to go back and find out where power control comes from, probably from the microprocessor. And it goes up through this diode D942. I guess we could look at the anode of D942 and see if we have any voltage there and see if it's just being told to turn on, but this regulator is not actually turning on. So let's go ahead and try to find that diode, D942. Okay, so way over here on the upper left portion of your screen, there is D942. So let's look at the anode voltage on it. I have negative 25 volts. 0 on the cathodes. Okay, so here is the microprocessor right here. This is pin 1 right here, and then pin 15 and 16. We can check it on this capacitor right here. I've only got 4.2 volts. That's a little bit low, because I should have close to 5 volts if my 5.6 is okay. Okay, so I'm low on pin 15 and pin 16. I've only got 4.2, and I should have close to 5 volts. So I know that that is derived from this 5.6 VA source, which I know is good. And so if I come over here, I go up, I go through this D101, which I've checked, and it is good. I get 5.6 on this side and 5.1 over here. And then I should go through Q104 when it's turned on. And then that is going to be my 5 volts for the microprocessor over here. And so Q104 is controlled by Q105. And so Q105 is controlled by this IC102, which is a reset IC. When it receives voltage, it momentarily shoots this low and then back up high to perform a reset on the microprocessor. So let's look at pin 1 and pin 3, and we can check pin 2 for ground integrity. Okay, so this right here is Q102. This is the reset control IC. And so if we look at pin 1, I see 2.2 volts. We should have close to 5 volts here. There's pin 2. Let's check for ground integrity. 0.3 ohms, we're good. And pin 3 is only 0.084. I need pin 3 to be close to 5 volts so it can turn on Q105 and turn on Q104. So why do I only have 2.2 volts on pin 1? Let's find out where that supply actually comes from. Okay, so if we follow pin 1, it's this supply right here. We follow it down, and it goes to a pin labeled Power Sense to the interface section. And through the interface section, it ends up on this connector on the power supply, pin 13. So if we follow pin 13 up, it comes out of the standby power supply. Could it be something as simple as a capacitor, C931? Could that be the whole problem? I should have just ESR'd the caps first. Anyhow, let's look at the power supply board, C931, and see if we have a bad cap, high ESR. Okay, so I've got my ESR meter out, and I'm going to check C931, which comes off of the transformer on this pin, goes through this jumper, across here, there's the diode, and there is the capacitor. The needle barely moves. It's 200 or 300 ohms of ESR. That's absolutely terrible. Well, let's go ahead and replace that, and I think I'm going to, in addition, go ahead and do the test I normally do where I unsolder the positive lead of all these capacitors, and we'll just check their integrity as well. Okay, so I have the culprit out of the unit right here, 2.2, 50 volts. So let's ESR it out of the circuit. It's probably a little over 200 ohms. That's absolutely terrible. Okay, so as you can see, I have the positive lead of all of these capacitors unsoldered that I've marked with a red circle. And then this is where the 2.2 goes, the one that I just tested that is defective. In addition, we have some capacitors down here, 4 of them. I've got those unsoldered, and we will ESR all of those. Now, I'm not going to unsolder the AC input caps because normally they're not part of a pi filter network. They just go through a diode into the capacitor. And the same way over here. Lead integrity is good. We'll check the pad, make sure we get no movement. That one's good. That one's good. That one is about a half an ohm, and it is a 220 microfarad. So a little high, but not anything to end the world. What I'm really looking for is a really high ESR cap. Now that's a main filter cap. That one should be 0. This one should be 0 as well. It's maybe 1/10 of an ohm. I'm going to call that one good. Half an ohm. 0. 0. Check the pad. Nope, pad's good. And we'll check the pad. Nothing. And the capacitor is half an ohm. I'm happy. All those are good. Let's come down here. Almost an ohm. That one's fine. They're small little caps. Just under an ohm. Now way over here. 2.5 ohms. We'll check the value. And almost 1 ohm. So let's check the AC input filter caps. That one's a little bit high. 1.5 ohms. I think it's going to be fine. 0 and 0. Those are good. Yeah, I think we'll let this one fly. It's only a 47 microfarad capacitor, and to get 1.5 ohms, almost 2 ohms on a 47 is perfectly fine. So let's get a new 22 microfarad capacitor in right here. Alright, so I've got a brand spanking 22 microfarad 50 volt capacitor. Let's go ahead and check it. And we get about 0.5 ohm. That's way lower than I expected. Anyhow, it's way better than 200 ohms. So we'll pop that in. I'll go ahead and solder that one up. We'll solder all the rest of these up as well, and we'll put it back in the unit and see if we get better results. And just because I see a little discoloration right here, this diode's been running warm, might be a bad solder connection. I'm just going to go ahead and solder that one up as well. Okay, I've got my meter set up here, and we're going to go ahead and look at pin 1 of that reset regulator. Remember, we had 2.2 volts last time. Power on. We have 5.1 volts now. And so that means pin 3 should have a higher voltage, 4.3. That is totally awesome. Well, let's go ahead and check this capacitor, which is the filter for the input, and I've got 4.9 volts there now. Let's see if we get a different reaction. Okay, I've got it back together. Let's switch the power on, and I get a red power light. We'll hit the power button, and we get welcome. It's working. Let's go ahead and hook up some speakers to it. Well, there I have some audio playing. And of course I don't want to get a copyright strike, so we'll stop the audio from playing here. Let's go ahead and try a DVD. Well, I decided I would go ahead and pull the top off of the DVD mechanism and go ahead and clean the optical pickup. And oh my gosh, look at that. So that's a flashlight shining diagonally on the optical pickup. And look at how much dust is on there. Holy crap. So I tried to get it to play a CD and it would not play even an audio CD, and I see why now. I'll bet you half the laser light is obstructed by this dust on the lens. Remember, the laser light has to go up through the dust one time, read the disc, pass through the dust a second time back to the optical pickup, and actually read the data. And there's no way it's going to read it through all this gunk. So let's go ahead and get a cotton swab and some glass cleaner and make this baby shine. Okay, so I've got my cotton swab. It's got glass cleaner on it. It's not soaked. I've wet it and I've shook it off. So I'm just going to go ahead and start by going around in circles. Always clean the optical pickup in a circular motion. Rotate the cotton swab to get a clean part. Now we'll go ahead and dry it off. Rotating it once again. Look at the difference. Oh my gosh. Well, let's see if it'll be more receptive to playing a disc now. Okay, well, I got it all back together and the disc would not open or close intermittently. I could hear the motor running, but I know it wasn't turning, so I went ahead and I pulled the top off of the DVD mechanism and I got to the drive belt, which is here. And as you can see, the drive belt has been sitting in one position for way too long and it's very glazed. So I'm going to go ahead and take my solvent of choice, acetone, and we're going to clean that belt. So I have a paper towel. I'm going to insert my finger into the acetone. Just flip it up. I got my paper towel nice and wet. Next I'm going to fold my paper towel twice and just pull the belt through it. And that's going to remove a tremendous amount of gunk off of this belt. Feels much better. Let's go ahead and clean the pulleys right now. So I'm just going to dip my swab in the acetone. I'm just going to put it in the groove. Now the acetone will melt this kind of plastic, as you can see right here, but it will not melt the nylon. And I've never had it melt a motor pulley as well. So we're going to clean the motor pulley. And then we'll put the belt back on. Oh, it's got plenty of pull now. That's really good. Okay, so I'm going to put the top back on it, and I'll try to play a disc in it one more time. Alright, while I have it loosely assembled, let's hit play. There's the volume. So it's playing, it plays the CD okay. And I just got to go ahead and reassemble it, put it all back together, and ship it off. Alright, well it's all back together. Let's hit the power button. And there is some audio. Turn the volume up. And so this is a successful failure. I repaired the power supply, the unit is up and working, but unfortunately there's a problem with the DVD mechanism. It will occasionally open the drawer and accept or give back the disc. Most of the time the mechanism has a problem raising and lowering to whatever disc it wants to play. Something's bound up. I've taken the mechanism apart, I've cleaned the belt, I've lubricated it, it still wants to be fussy. I've cleaned the switches with deoxid, everything looks good, it just needs a little bit of help. I'm going to give it back to my customer as is, unrepaired. At least it works. My customer can use it as a stereo system for their TV. If they have an external DVD player, they can decode it with this, because it does have an optical input jack, so they could use an external DVD player and still decode the 5.1 audio with this. Anyhow, that's it. I hope you enjoyed this video on the LG partial repair LHT764. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everybody have a great day. Thanks for watching. Bye-bye.